Hello, hello, hello. Good evening, everyone. Good evening, Shillong. I hope you all are good. Can you please mark your attendance, Shillong Center? Is there anyone in Shillong? Good evening, good evening. It must be San, I guess. What is the attendance? 1, okay. And you can hear me properly, you can see me, right? Okay, guys. So we have almost covered all the topics, all concept in permutation and combination. But yes, today we will also, we will do one more class on PNC so that we will be covering all kind of miscellaneous problem, right? Starting from NCR, NCP, permutations, combinations, and all of these, smaller topics. So that we are going to cover, right? And I hope that you guys have started solving NCRT as well, or your textbook, right? Not an issue. But if you have not, so not an issue, because today I'll be taking all those questions in the classroom itself. So mainly I'm going to discuss the problems which is given in NCRT exercises, which is quite common to the state textbook as well. All right, everyone? San, how are you? Have you started solving NCRT? Don't say no to me. Say, yes, sir, I have started, because this is almost 4 classes I have done, right, on PNC. And today we will wrap up this chapter completely. And of course, there is a lot of topics left for JEE Mains, but we will not cover that for now, right? All those topics, like 2 or 3 topics are there which we need to cover in class 12th, right, before your exam. But yes, talking about board exams, we have done a lot. We have done a lot of problems, all kind of like starting from easier, then modest level, and then moderate level, and then the toughest level. We have did that. Okay, San is not the Lahnam is there. Okay, very good, Lahnam. If you started, very good. Tell me, do you have any camera in the classroom? Okay, not an issue. Okay, so let's start now, because rest of the students will be joining us. All right, and we are not starting any kind of new chapter or new topic. So let's start with the questions itself. Question is, find x. Question is, find x if 1 upon 8 factorial plus 1 upon 9 factorial equals to x upon 10 factorial. This is also 10 factorial. This is how I write 10 factorial. So both are same. Okay. 1 upon 8 factorial plus 1 upon 9 factorial equals to x upon 10 factorial. What is the value of x? What is the value of x? See, important. Any n factorial, we remember, can be written as n into n minus 1 into n minus 2 and so on till 3 to 1. Also, n factorial can be written as n times n minus 1 factorial. If needed, I can write n minus 1 and then n minus 2 factorial. Is this clear to all of you? Yes. Now you see, 1 upon 8 factorial, I think 8 factorial will be common to all of these. 9 factorial can be written as 1 upon 9 times 8 factorial equals to x upon 10 into 9 into 8 factorial. Yes. Why I am writing so? Because, I can cancel 8 factorial from each and every term. What we are left with? 1 plus 1 upon 9 equals to x upon 90. This is 9 plus 1 upon 9 equals to x upon 90. So on solving we get 10 by 9 equals to x by 90. What is the answer, guys? X will be 90 into 10 divided by 9, which is x equals to 100. So value of x equals to 100. Copy it. And if any doubt, let me know. Lehnam. Okay. Copy it, take your time. And you should also realize why we have not done anything with 8 factorial, right? Because 8 factorial is something which will be there in each and every number, whether it is 9 factorial or it is 10 factorial, right? So instead of writing 8 factorial, better if we can cancel it. That's the whole motivation of this problem. Next is, have you copied? Lehnam? Tell me. Very good. Next problem is, question is 3 factorial plus 4 factorial equals to 7 factorial? Is this true or false? Such a beautiful question. Is it true or false? 3 factorial plus 4 factorial equals to 7 factorial. Is it true or false? Okay. And then again, 0 factorial plus 1 factorial equals to 2 factorial. Is it true or false? No, Lehnam, please think about it. What is 3 factorial exactly? What is 4 factorial? Then reply whether it is same or not. See, 3 plus 4 is 7, no doubt. But that doesn't mean that, if we apply factorial, after that it will be again applicable. Like 3 factorial, and if you add with 4 factorial, they will give you 7 factorial, right? Check it, you know all the values. Yes, check it, all the values. It's okay, nothing to do sorry about. Just do not answer it randomly. You please solve it first and then reply. Okay? Just think about, you are sitting in exam and you will be awarding marks. If you will answer it incorrectly, you will be negative. You will be getting negative marks. If you would answer it correctly, then you will get positive marks. So think about that way. Otherwise, we can say anything like true, false, no, answer is not there, none of these. There are so many things we can talk of them, right? So yes, first is false. Very much false, right? And the second part, 0 factorial plus 1 factorial equals to 2 factorial is true. So the idea of these two parts, why I have asked you these two, because always remember, this is not always valid. Like if n factorial plus some other x factorial plus some y factorial will give you x plus y factorial. No, that is not always true. But yeah, there is one case, which is this one. 0 factorial plus 1 factorial will give you 2 factorial. I mean, I'm talking about consecutive numbers. So there is nothing you have to note down as an important note, or you should remember something. Nothing like that, right? You will get a question, think about those numbers, those values, and if they match, answer will be true, otherwise it is not. Simple. Next question is, find this value, find the value of n such that n such that first np5 equals to 42 np3, right? 42 times np3, where it is given that n is greater than 4. Second part is also given. It is np4 divided by n minus 1 p4 equals to 5 by 3. It has the same condition, n is greater than 4. You have to find the values of n in both cases, right? Forget about n greater than 4 or what is the condition. What is the condition on n? For now, first you have to solve it. You have to solve this and you will check, okay, what are the allowed values of n on both the sides, right? Solve this one. Now what is NPR? NPR is n factorial divided by n minus r factorial. There is no r factorial in the denominator, right? That is NCR. Is that clear? So you see, np5, what does that mean? N factorial divided by n minus 5 factorial equals to 42 times of n factorial divided by n minus of 3 factorial, right? Now, what is n factorial divided by n minus 5? You must remember this: n minus 1, n minus 2, n minus 3, one more, n minus 4, and then it will be n minus 1 factorial onward. So this is n minus 5 factorial. Divide by n minus 5 in the denominator. Equals to, in the right side we have 42 times n factorial, n minus 1, n minus 2, and then again n minus 3. You should not write n minus 3 completely because n minus 3 factorial is in the denominator as well, so they will get cancelled. N minus 3 factorial. These two gets cancelled. Similarly, n minus 5 factorial gets cancelled. Right? So now, n minus 1, n minus 2, n minus 3, n minus 4 equals to 42 times n minus 1, n minus 2. We can cancel these three also. Now, observe this: n minus 3, n minus 4 equals to 42. A simple quadratic, right? Let's solve this one. N square minus 3n minus 4n plus 12 equals to 42. N square minus 7n. This is 42 and this will be minus of 30. Right? N square minus of 7n minus 30 equals to 0. What are the factors? It is n minus 10 and n plus of 3. We need two numbers such that their addition will be minus 7 and their multiplication is minus 30. I think those numbers are minus 10 and 3. Is that clear? Now, if this is 0, you will get n equals to 10, or if this is 0, you will get n equals to minus of 3. Now you see, these are the values of n equals to 10 or n equals to minus 3. But guys, always remember, n cannot be a negative number. And also if there I have written np3, np4, whatever. Always remember that any NPR or NCR, right, they are never negative. There is one more condition given on n, which is n greater than 4. So yes, certainly only n equals to 10 satisfies the given condition. So n equals to 10 will be your answer. The only answer is n equals to 10. Tell me if any doubt. Lenam. N equals to 10 is the correct answer. N cannot be negative. Very good, very good. So can you do the second part? Attempt this one. NP4 divided by N minus 1P4. Do this one. NP4. What is NP4? N factorial divided by N minus 4 factorial divided by N minus 1 factorial divide N minus 1 minus this, right? So it will be plus 4. Sorry, it's not plus, it's minus. This whole minus 4 and minus r equals to 5 by 3. This is given to us. So now guys, this is n factorial divided by n minus 4 factorial times it will be n minus 5. This is n minus 1 equals to 5 by 3. You check this one. You will get n factorial divided by n minus 4 factorial. Then this denominator term, I am rewriting it. When you do that, this will be in the numerator and this is in the denominator like this. Yes, right? Let's solve this. N into n minus 1, right? Similarly, tell me n minus 4 is greater or n minus 5? Of course, n minus 4 will be greater than n minus 5. So this is something which is greater than this. That means n minus 4, one term will be here and then it will be n minus 5 minus 1. Always remember, you can say that, you have replaced n with n minus 4. So it will be n minus 4 and it is n minus 1, which is n minus 5. Why I am doing so? Because n minus 5 are present. I mean n minus 5 and n minus 1 both are present. 5 by 3. Let's cancel. So we are left with n upon n minus 4 equals to 5 by 3. If you solve it, you will get 3n equals to 5 and minus of 20. This will be 2n equals to 20, n equals to 10. So again n equals to 10. Yes, very good. N equals to 10 is the correct answer. All right, very good. Let's do the next problem. Question is, if tan c x equals to tan c y, then option A, x plus y equals to tan B, x equals to y, C, x equals to 2, y equals to 7, D, x equals to 6, y equals to 4. This is more than one correct type. So please take care of the options. You have to check all the options, right? More than one correct type. More than one correct type. If tan cx equals to tan cy, then x plus y equals to 10. Of course, x and y both are natural numbers. So don't worry about that. I mean, whole number, not natural. Very important. If you know it already, well and good. Otherwise, you please copy it. NCR. To define NCR, what are the conditions? First of all, n has to be a natural number. Secondly, R has to be, this is natural number, right? This is natural. It means The minimum value of n can be 1, then 2, 3, and so on, right? R you can take starting from 0, 1, 2, all of these positive integers, including 0. And the last, which is very important, that n is greater or equals to r. So these are three conditions which should be satisfied when you define NCR. These three are very much important. Please write it. So what are the answers? Out of A, B, C, D, if tan Cx equals to tan Cy. Come with your answers. Renam, what are the answers? Okay. A, option A, it says x plus y equals to 10, which is nothing but, yes, x plus y equals to n. If two NCR, right, NCR1, NCR2 is same, so that means that R1, R2, either they are equal or their sum is equals to n. Always remember, guys, this is very important. Like, this is the first to define, and second, I have told you so many times this, right? NCR equals to NCY. What does that mean? There are two conclusions out of it. First, that x equals to y. Second is that x plus y equals to n. Always remember this. Very, very much important. Either they are equal, so their NCR values will be same, or if their summation is n itself. A is correct, B is correct, C. Let's check this one. If x is 2, y cannot be 7. Y has to be 8 then. This is not correct. If x is 6 and y is 4, yes, this is correct. So what is the correct options? Options are A, B, and D. Three options are correct. A, B, and D. Any pair of x and y for which x plus y will give you 10 will be the answer of this given equation. Okay? Next. Any doubt, anyone? Next is, very good question is, find the number of ways of arrangements of the letters of the word independence. Independence. All right? Now, apart from this, also find in which you have to find the number of ways in which, first, do all the bobbles do all the bubbles occurs together, right? Occurs together. Second part, do the bubbles never occur together, never occur together. Third is, do the word begin with I and ants in I, ants in capital I. No, it's not. There is no 2P. Ants in P. So yes, there are total of 4 parts in sort, right? First of all, you have to find the total number of arrangement where repetition is there, right? Some of the objects are repeated, so that you have to take care of. And there are some more parts like first, second, third, in which some bubbles, all the bubbles are together, and then no 2 bubbles are together. And lastly, do the words begin with I and ends in P. So these are the 3 parts which you have to solve. Now tell me the answer for first part. Let me count how many I's are there. 1. How many N? 3. How many D? Only 1. How many times E? 1, 2, 3, 4. So that is 4. How many times P? Only 1. E is covered, N is covered, D is twice. Covered, E is covered, N is covered, C. 1 time E is covered. So how many total? 1 plus 3 plus 2, 6, 10, 2, 12. And here we have 3 plus 3, 3 plus 3. So yes, total of 12 letters. Is that clear? So total number of ways. What are the total number of ways? You don't need to write down the final answer, just write the number itself. 12 factorial divide by the repetition now. 3 factorial, 2 factorial and 4 factorial. This is the answer. Next. And today I think we can wrap up by 5 o'clock, right? Yes, you have it heard it correctly. We will wrap up by 5 o'clock today, because we are just kind of doing revision. So there is no need to go till 5:30. First part now. Do all the bubbles occurs together. Find in which do all the bubbles occurs together. Now you tell me, how would you solve it? If you have to make all the bubbles together, means N, D, P, and D, and C, right? So these are total of 7, and I, and 4 times C. So they are total of 5, sorry. So I'll consider them as a single unit now, right? They are all single unit. Now you tell me what is the answer. Now you tell me what will be the answer. This is very much important. When all the bubbles together. Answer would be number of ways. When all the answers together, it would be half what? 1, 2, 3, 4, 5, 6, 7, 8. Total of 8 units, first of all, 8 units, right? Now we will divide by 2 factorial corresponding to D and 3 factorial corresponding to N. There is nothing we have to divide, we have to divide for E, because E and I, all these 5 elements we are considering as a single unit. Is that clear? So yes, 8 factorial divide by 2 factorial and 3 factorial so far. Next, into, now this is done with this completely, right? But you know that there will be some intra arrangement also within I, E and all the bubbles. So that will be what? 5 factorial divide by 4 factorial. So a simple, again the simple formula, that repetition one. So that this is the answer. No need to solve again. Just write down the number. Yes, correct. Very good, very good. Let's find out the second part, when no 2 bubbles are together. What is the answer? See, this is important now, because you have to understand the question is, do the bubbles never occur together? So is it about like all the bubbles or any of the 2 bubbles? Because we know how to solve if it is for, regarding 2 bubbles, or if it is regarding all the bubbles. So my question is, do the bubbles to any number of bubbles will never together, to any 2 bubbles, any of 2 or more bubbles. Basically we have problem if they are 2 in number, if they are occurring 3 in number, or all together. So we have all problems, right? Now this question is more specified. Is it clear? So this will be solved with the help of gap method, right? Gap method. Guys, what is gap method? Gap method says, let's arrange first of all these, all the unrestricted elements. So those are N, D, P, N, D, and C. Right? How many gaps you will get? 8 gaps, and then we will arrange them. Anyway, so how many ways you can arrange all these unrestricted elements? That will be 8 factorial, no, sorry, 7 factorial, divide by 2 for D, divide by 3 for 3 n's, right? 3 factorial. Now, out of these created 8 gaps, you can choose any 5 gaps out of these 8 gaps. In how many ways? 8C5. Now, further, how will you arrange all the bubbles? 5 factorial divided by 4 factorial. This is how you will arrange. That's your answer. Is that clear? This will be the final answer if no 2 bubbles or any number of bubbles cannot be together. Say yes or no. Next, third part. Do the words begin with I and ends in P? I and P. Here we have fixed I and here we have fixed P. Now the whole struggle is for remaining 10 places. So 10 factorial divide by how many? I and P both are 1, 1. So, of course, we have to divide with 3 factorial, 2 factorial and 4 factorial. This is the answer. And you see, you cannot multiply 2 because I and P are being fixed. I has to be at the starting, at the beginning, and P has to be at the end. So there is only one way to arrange I and P within themselves. So the total number of ways will be this one. Any doubt? Okay. Next question. How many words with or without meaning can be made from the letters of the word Monday. Assuming that no letter is repeated. If, now we have some cases. First, 4 letters are used at a time. Second part is all the letters are used at a time. So this is the question. Solve it. How many words with or without meaning can be made from the letters of the word Monday, assuming that no letter is repeated? You are not supposed to repeat any of the letter. If 4 letters are used at a time, all the letters are used at a time. Permutation and combination, I think, is this chapter, is all about understanding the question. If repetition is there, what will be the approach, how you would think about it? If repetition is there, if there is not, what is the difference? If all the letters, if some of the letters. So all of this you have to understand. Mathematics is very easy then. Once you will be realizing what is the question exactly. You see, no repetition, yeah, got it. No letter is repeated, not repeated. Okay. And then we have Monday. So 4 letters we have to use. First part. How many words will be there? Number of such words or number of ways of such words will be, see, out of given, how many letters are there? 6. Choose any 4. C, 6, C4. You will choose any 4 letters out of given 6 letters. For an example, I have taken MODA. I have taken MODA, these 4 letters. Now, in how many ways you can arrange them? 4 factorial. So that's your answer. So that's your answer. Is it clear? Next. Second is, all the letters are used at a time. Means all the letters, that means number of such words will be 6 factorial. Why? You can directly comment over 6 factorial or make a story. What story? Let's select 6C6. Let's select 6 letters out of given 6 letters and then arrange them. So, well, this is 1. You will get the same 6 factorial answer from both the method. Is that clear? Guys, if I were to ask you if repetition is allowed, find out the answer if repetition is allowed. Again, same, both the parts, find out the answer first. Number of words. We have done the same problem, right? Where some powers will be raised. Question is same, dear. Question is the same question. Here, there are no letters repeated. We have not allowed letters to repeat. Here, repetition is allowed. So, if Monday is there, you have to make 4-digit number and again, kind of all using all the letters and here only 4 letters, but repetition will be allowed. If 4 letters are used at a time, what does that mean? That means it is simply 4-letter words, nothing else, 4-letter words, right? So if there are total of 4 spaces, in how many ways you can fill them? 6 ways, 6 ways, 6 ways, and again 6 ways. So what is the answer? 6 raised to power 4 is the correct answer. Is that clear? 6 raised to power 4 is the correct answer. For the second part, there will be total of 6 again. Because you have to take all the letters. You can take all the letters. So it will be 6 spaces now. Is that clear? Well, see, this is important here. I'm not saying that this question is allowed. I mean, framing should be different. This question I cannot ask you, right? I understand that you understood. If this is the question, how you would solve, how this is 6 raised to power 5, I mean 6 raised to power 4, and the upcoming will be 6 raised to power 6. But I am saying that no, framing is not good. The kind of question is being asked now is only possible when not allowed. Repetition is not allowed. So you have to understand this. Right? This is the reason I have told you. I have asked you this. But yes, if somebody will ask you such kind of silly question, still you can answer. Or if there is any option called none of these, go for it. That is the most appropriate then. Okay? Okay, the next question is, yes, this is a good one. prove that NCR plus NCR minus 1 equals to N plus 1 CR. Prove this. Of course, proof, then we can take any of the side. There is nothing to do with, what do I say, right hand side for now. So we can consider LHS, right? LHS. What we are given in LHS? It is NCR, which is n factorial divided by R factorial n minus R plus n factorial divided by R minus 1 factorial and n minus R minus, which will get plus 1. You have to understand this, like this is n minus 1, n minus 2, and then you will be getting somewhere n minus R plus 1, which is higher, right? And then n minus R minus 1, and so on. Then keep doing it, 3 to 1. Is this clear? Now. Okay, so what is the motivation of it, right? You need to make this n plus 1 somehow, okay? Anyway, what is the common we can take out of these two terms? N factorial we can take out. Let me take n factorial out, okay? And then again, I can take out R minus 1 factorial also, because R into R minus 1. And this is what n minus R plus 1. So yes, n minus R I can take out. Is that clear? I can take out n minus R. Now, take help from this. Take help from this. Okay? This is 1 upon R, simply 1 upon R, and that's it, nothing else, right? 1 upon R. And here we have plus 1 upon, this will be R minus 1 already, so I have taken R minus 1 factorial common. This is n minus R plus 1, right? What we have taken out? N minus R. So basically this much of factorial we have taken common. What is this total factorial? This will be this term into the given factorial. So what we can write is n minus R plus 1. And now we are done. If you understood, there is nothing left. N factorial divided by R minus 1 factorial n minus R factorial, and this will be R into n minus R plus 1 multiply with n minus R plus 1 plus of R, simple calculations, right? R gets cancelled. We have n factorial times n plus 1. See, we have got n plus 1, right? Yes. Next is R minus 1, this is R, right? Always look into the right hand side, what you are supposed to prove, which is given R. So what we need is R factorial. Okay, let me write here for a while, let me write here exactly what does this expression mean. N plus 1 factorial, R factorial, and then n plus 1 minus R, which is nothing but n minus R plus 1. Something like this we have to prove. Are we good? Next. N factorial into n plus 1, and this is R minus 1 factorial. If you multiply this with R, you will get R factorial itself. Total of R factorial, right? Now this is what n minus R, and this is n minus R plus 1. This is n minus R factorial, and if you multiply with this term, so what do you get? You will get n minus R plus 1 factorial. I think we are done. This is nothing but n plus 1 factorial, and this is R factorial, and this can be written as n plus 1 minus of R, which means n plus 1 CR, hence proved, equals to RHS. Is this clear? This is how we prove. And remember, today I'll be wrapping this lecture at 5 o'clock, right? Because we have almost revised it, nothing to worry about. Okay. Any doubts so far? Clear, very good. Next question is, and probably the last question for the day. And guys, in the next class, we will start new chapter, which will be straight line. Straight line, circle, and then conic, right? And after that, we will be almost finishing the 11th mathematics. Yeah, but anyway, question is, how many numbers greater than 1, 2, 3, 4, 5, 6 can be formed? So basically, yes, you have to find out the number which are greater than 10 lakhs formed by using the digits 1, 2, 0, 2, 4, 2, 4. Is that clear? So you have to find the total number of such numbers. And of course, when I'm saying 1, 2, 0, 2, 4, 2, 4, that means repetition. Don't talk about repetition, because already letters or numbers, sorry, not numbers, letters or digits I have provided you, they are already repeated. So question is basically, this is seven places, right? These are total of 7 places. And these are 7 letters, 7 digits. Sorry, 7 digits, right? Simply you have to substitute, or you have to fill in all these digits in these spaces. Simply. Don't think about repetition is allowed or not, or what are the other digits available. No, there is nothing. You can pick any 2, 4. I mean, you can fill in 4 twice. 2 you can fill in thrice, 0 one time, and same as 1 time. So this much you have to do. Now tell me, what is the answer? Okay, so how you will do that? Numbers greater than 10 lakh can be formed using the digits. How you can solve this? See, there is one 0 available. 0 you cannot substitute here, right? Is that clear? You cannot put 0 here. Okay, there is a different method, I think. Like, you see, any number, if you start with 1 and start filling anything like out of these 6 places, 6 digit, start filling, this number will be certainly greater than 10 lakh. Agreed? If you start with 2, again start filling, it will be greater, of course. If you put any of the 4, start filling it, again it is higher than the required number. So yes, all these cases are certainly the required one. When you will fill 0 here, this is not even a 7-digit number. This is undesired case. Okay, we are good so far. What are the number of ways in which you can fill in all these 7 spaces? So definitely that will be total ways of filling these 7 digits into 7 spaces is nothing but arrangement of 7 objects, out of which 2 are same, 3 are same. So yes, if you agree. What is this number? We are getting this number as 7 into 6 into 5, 4, 3, 2. Divide by 2 into 6. 3 factorial is 6. So these we have cancelled. Now what we have is 20 into 21, which will be 420. Right? 420. Now, in all these cases, I mean, when we have counted 420, in these numbers, what happened exactly, na? You have counted, you have overcounted actually. You have overcounted some cases. What are these cases? Numbers which starts with 0, because there will be some numbers which will be starting with 0 as well. Those are not the desired numbers. Right? How many? So if I fix 0 at the very first place, so now we have to take care of remaining 6 places and according to the given orientation or configuration. So that will be 6 factorial divided by, which has been fixed. 6 factorial divided by 2 factorial, 3 factorial. Now what is the answer? 6, 5, 4, 3, 2. 2 into 6. 6, 6 cancel, 2, 2 cancel. This is 60. So yes, required number of such numbers will be and total such numbers will be basically 420 minus of 60, that is 360 is the correct answer. Sorry. Did you get it? I mean, this is the most easiest way. Otherwise, there are so many things you can do with this. Yes or no? Okay, so if you are done with this, this is the end of our chapter permutation and combination, and I hope you will do all the questions given in NCERT or the material you have. Most importantly, if you have any doubt, you will ask me at the same time. You will not wait for the next class. Right? We are active on WhatsApp. You can ask all the doubts over there, and I will reply maybe on the same day, maybe the next day. But yes, be serious. Start attempting the question. Okay. So guys, this is all about permutation and combination, very most important chapter for class 11th, and this is not only for class 11th. This chapter will be helping you a lot, in probability directly, and there we can generate some question in function as well, determinant. Whenever it comes to number of ways in any of chapter, like number of such function, number of such particular function satisfying this condition, or number of such determinants can be formed. You are not getting what is exactly determinant, but yes, there are some things which indirectly use this kind of chapter, permutation, number of ways. But yes, I think we have, we are good at a base thing, confident enough because we have done a lot of problems into this chapter, and just attempt all the questions as much as possible. You can like as much as question you can do now, that will be giving you confidence, right? And start thinking different approaches. Look, okay, like this is what I am thinking. Should I attempt with this? Yes, do that. Now, what sir exactly told me about this kind of question, how we should approach? Okay, start with that also. Find out if you're getting the same answer or not. If not, then there is some problem in your method, not my method, right? So then you have to ask me. So that is how we learn. I still remember when I was a kid, like in 11th, 12th, I used to do any problem. I used to do at least with 3 or 4 methods. This is not possible with each and every problem, but yes, it will certainly enhance your how you think, how you start thinking. If any problem will come to you, you can easily think of the formula. But if you are good with the language first of all. You have to understand the language, the differences between all kind of like repeated, non-repeated, identical, difference. Those you have to understand. All right. So yes, this is for the day. This is all for the chapter permutation and combination. And in the next class, we will start with straight lines. So take care, everyone. Take care of your health and keep asking your doubts. Keep learning. Thank you.